All right, welcome everybody. Today we're going to be doing a webinar on ATSC 3.0 again. I did one of these in May timeframe where we looked at the technology, the standards, and how the whole standard works. Today we're going to take a little different angle and look at reuse of that ATSC 3 content. And so look forward to walking through this with you all. Just want to highlight here Sencore's fall virtual events series. So for the last 3 days, we've been doing a series of webinars. This is the last and final webinar today. So if you're interested in seeing what you missed the last 2 days, they're all on our website, and you can view the recordings of those. So my name is Seth Vermolm. I'm a senior product manager here at Sencore, responsible for a lot of Sencore's test and measurement equipment product lines and various other product lines. And also one of the point people here on our ATSC 3.0 development. And with me today, I've got Aaron Doughton as a panelist. Aaron's one of the other product managers here at Sencore. And I've also got Jason Dabbert, one of our account representatives here as well with me. So these two will be handling the questions that come in, and we'll be stopping throughout the presentation to ask and answer those. So if you have questions, go ahead and type them into the Q&A chat window of the Zoom meeting, and we'll make sure those get handled and answered. All of our contact information is here on this slide, so if you have further in-depth conversations you want to have, or any other follow-up questions that come to your mind later, absolutely feel free to reach out to one of us or contact Sencore on our website. So the agenda for today, like I said, we're going to be talking about ATSC 3.0 reuse. So we're going to really have 4 sections to this webinar here. Just a quick look and review of ATSC 3.0 technical info and a comparison with 1.0. I went in-depth into this back in May, like I said. If you want to review that or go back and look at that, that recording would be on our website as well. So we're just going to touch on it a little bit, highlight a few things that are pertinent to the conversation today. Then we're going to do an update on the ATSC 3.0 rollout and the rules that are currently active. And then we're going to jump into the meat of the presentation, where we look at ATSC 3.0 reuse for MVPDs. So let's see how that can be done. And finally, we'll take a look at a few Sencore products for ATSC 3.0 that relate to this presentation and give us some background there. So this is really the most important slide as it relates to the conversation today. My point on this slide is just to highlight how different ATSC 3.0 is from ATSC 1.0. You know, ATSC 1.0 has been on the air here in the US starting in 1998, and you know, the final transition in the 2008-2009 timeframe. So basically 10 to 20 years, all of these ATSC 1.0 broadcasts have been on the air. ATSC 1.0 was built around an MPEG transport stream as the wrapper, the container, 8 VSB modulation, MPEG 2 video, and AC3 audio. ATSC 3.0 really throws just about all of that out. it uses an OFDM type modulation. The MPEG transport stream is gone, replaced with replaced with IP wrappers, and then the actual video and audio essences are carried in route or MMT packages. The video compression is HEVC, the audio compression is AC4. Even the caption formats are different there. So yeah, the point is really nothing is the same between these two, and in order to facilitate the reuse that cable, telco, direct-to-home satellite providers need to do, many modifications will need to be done to the signal. So, a couple other highlights, just like I said, relevant to the discussion today about reuse is just highlighting the subtitles, the captions of the ATSC 3.0 signal. So SMPTE time text is the format that is used. We're all used to the 608, 708 format that's been around. 608's been around since the 1970s. 708 has been added with ATSC 1 basically in the 90s. So a long time for those older formats. The new standard is SMPTE time text. It's basically an XML file with a string of text and some other metadata around that related to when to put it on the screen, where to put it on the screen, things like that. So the ATSC 3.0 standard also calls out a subset. So the SMPTE time text standard is very broad. ATSC 3.0 narrows the options there a little bit, but basically allows for both ASCII text-based characters and picture or non-ASCII characters. So really combining some of the different features from 608, 708, teletext, and subtitles all into one standard. I did add a line here from when I used this slide earlier that it is possible, and the ISMC1 standard does call out a way to stick the 608 and 708 caption data into the SMPTE time text XML file. My experience in most of the streams I've seen so far is that broadcasters are not doing that, but if they would, it certainly would make some parts of the reuse a little easier, but we'll talk through that in a little more depth later. But that's the subtitles and the teletext. Also, just highlighting again within the ATSC 3.0 signal, the video and audio layers. As we talked about a little earlier, the ATSC 3.0 is using HEVC video compression, which supports and actually encourages UHD, HDR, enhancements to the normal video. So higher resolutions, enhanced dynamic range, all are supported in this, along with a lot of other things, 3D, and other enhancements that HEVC provides, along with the efficiency and compression that HEVC provides. But in going down that path with HEVC, there's certainly a lot of added complexity for encoders, decoders, and you can see some of the highlights there. Encoding HEVC as compared to H.264 is 40 times the the complexity decoding is 3 times, and that's just a comparison to H.264, not even MPEG-2, which is actually the ATSC 1.0 standard. You can probably double those numbers comparing it to ATSC 1.0 and MPEG-2. So definitely a major improvement there in terms of efficiency, but complexity comes with that as well. In addition to the video changing, ATSC 3.0 also makes use of AC4 audio. So this has got, spatial audio, lots of other fancy features, up to 12 channels of audio available in AC4. But that creates lots of complications when you're looking to reuse that in a system that doesn't support AC4. And we'll talk through that as we go through this presentation. So. All right, the next section here, I just want to review the ATSC 3.0 rollout and rules, and look at how the standard's coming along, how the rollout and deployment is coming along. So just a review here, really in November of 2017 was when the FCC first gave their blessing to start rolling out ATSC 3.0. They did it quite differently than the ATSC 1.0 rollout was done. It is not mandatory for any station to convert from 1.0 to 3.0. So it's elective for those stations. There is no, set-top box providing those to customers or end users. That's all optional as well. So the whole transition is very optional, but a lot of broadcasters are still taking it up and moving forward on this. The FCC did require full power stations to simulcast their programming in ATSC 1.0. So if they choose to broadcast in 3.0, they have to keep a 1.0 version of their signal on the air for 5 years. And we'll talk in the next slide about some clarifications on what that means. Most of the simulcasts we're seeing are where the broadcasters throughout a market band together, pick one of their transmitters to be an ATSC 3.0 lighthouse, and then spread the ATSC 1.0 simulcasts around on the other transmitters as multi-services on a single transmitter. So low power stations were exempt from the simulcast requirements. And again, it's optional for them to cut over to 3.0 as needed. So. And at the time, and still, the FCC said they're not planning to adopt a tuner requirement on new TV sets like they did for 1.0, but we are seeing now in the market the first TV sets. I know Samsung and Sony both have sets out that include an ATSC 3.0 capable tuner built right into it. So those are available at stores. It's the higher end of their product lines, but they are out there. We have one in our lab here at Sencore, and it works quite well. So the new slide that really reflects changes since my last presentation involves the FCC's second report and order on ATSC 3.0 that was released this summer. Basically, it does a bunch of clarification on the rollout and the standards. First of all, clarifies when stations can get a waiver to simulcast requirements. It also clarifies that sunset of the ATSC 1.0 simulcast requirement. So I said in the previous slide, the initial report and order required 5 years of simulcasting of 1.0. The FCC clarified that 5-year date ends on July 17, 2023. But they also admitted that they will look into that a year ahead of time. So 2022, they're going to review that and see if that 2023 date needs to be extended. So as of right now, the simulcast requirement expires in a little under 3 years from now. So the other big thing they clarified in that simulcast requirement is that you know, the term substantially similar was used in the original report in order to say what had to be in the 1.0 simulcast. And in this second report in order, they clarified that substantially similar does not necessarily mean the same resolution. So the broadcasters are not required to maintain HD if their signal was HD before in the 1.0 simulcast. So definitely some implications there for reuse as well. There was a push for use of vacant channels to do shuffling and temporary use during the transition. That was denied. And there was again a request to prohibit broadcasters from using retrans negotiations to obtain carriage of ATSC 3.0 signals. That was denied in the first report and order, and that was denied in the second one as well. So the FCC chose not to get involved in that retrans negotiation discussion there. So definitely some developments since our last presentation and look at this, but mostly the FCC just kept things going on the same path they were going on before, and added some clarification for a number of things there. So there definitely has been some updates in the ATSC on-air statuses, ATSC 3.0 on-air statuses, so you can see what it was back in May. You know, with the orange markets there on the air, the number of on the air markets has substantially increased in the last 6 months. I know, you know, with the pandemic situation, there was some definite delays related to, you know, being able to roll out these new transmitters, getting workers in place to be able to do those upgrades. It seems like that is starting to roll again. And, you know, there are definitely more and more on the air situations. You know, from the ATSC website, there was a note that they are still targeting 60 markets to be on the air in 2020 with at least one ATSC 3.0 transmitter. I kind of have my doubts that that's truly going to happen, but we'll see. I did update this, you know, slide as well here. So the new ones since this spring are the ones highlighted in orange there. So you know, where there was 6 before, now we've got 12 on the air throughout the country. Sencore has participated in a number of the test groups, and we've traveled out to some of these sites and done some real world testing and signal captures just for our own products and development. So it's out there on the air. We've seen existing stations that have been doing 3.0 for a while change the format of their signal, testing other configurations. We're seeing a lot more PLPs in the signals. So most of the original ones were single PLP. And now we're seeing a lot of multi-PLP channels out there as well. So just, you know, trying different things. Again, it's a lot of testing right now, and just making sure it works and seeing what problems and reception issues may or may not happen. So definitely making progress on ATSC 3.0 rollout there. So at this point, we're going to hop into the meat of the presentation here. So, you know, I really want to look at how MVPDs or multi-channel video programming distributors, that's a mouthful for sure. We'll stick with the acronym, but you know, that really represents the cable companies, the telcos, and the direct-to-home satellite guys that are collecting signals from various you know, cable networks, broadcast networks, local affiliates, packaging those into some kind of a service offering, a bundle that they're offering to their customers over some kind of medium, whether that's coax, fiber, or internet, or direct-to-home satellite. So, you know, 1.0, ATSC 1.0 has been in this, you know, retransmission, reuse with MVPDs for many years. Sencore has been very heavily involved in this process. You know, using our equipment to receive, turn around, decode the ATSC 1.0 signals for reuse in an MVPD system. And really, ATSC 1.0 made it very easy. And because, you know, the transport stream packaging is really the same packaging that's used in most of these MVPD systems. The MPEG-2 video, the AC3 audio are compatible with these MVPD systems. Many cable systems are still relying on, you know, MPEG-2 all the way out to the end user. The set-top boxes support, you know, MPEG-2. Definitely, some of these MVPDs have transcoded their ATSC 1.0 signals. You know, we've seen a lot of transcoding those into H.264 compression, just to take advantage of the efficiencies out there. But you know, you see the diagram at the bottom of the slide. So, you know, most of the MVPDs that are reusing local off-air signals in their system are either receiving it, you know, from the 1.0 RF signal, or they've got some kind of a microwave or fiber link to the actual, you know, local broadcaster, and are able to get that without that over-the-air hop. But even when they're doing that, you know, direct microwave or fiber, they often have the 1.0 RF signal as a backup in case something goes wrong. And then you see the optional transcode there on the diagram as well. So this is the current state of things. I'd still say most, if not all, MVPDs are still relying on the 1.0 signal. And whether they transcode or not is just dependent on their system. But in many cases, it's possible to take the ATSC 1.0 signal exactly as it is and stick it in the MVPD network, and everything works really well. So when it comes to you know, okay, what happens to that signal chain there for the MVPDs when ATSC 1.0 transmissions start going away? There's certainly the retrans agreements, you know, the reuse, the must carry, all that kind of those kind of legal topics play into this. And suddenly now the broadcasters are on the air with a signal that's not really compatible with the MVPD networks in any such way. So like we talked about, there's no longer a transport stream. There's HEVC video compression, which I'd say most MVPD systems, set-top boxes don't support at this point. AC4 audio is the same way. Captions are definitely another big consideration there. So the SCTE, the Society of Cable Television Engineers, and various cable companies have been pretty open with their objection to the the forced ATSC 3.0 retransmission. So they've filed a number of opinions with the FCC related to ATSC 3.0, had discussions, put out press releases, etc. Somewhat, I'm sure, anticipating that, or in response to that, the ATSC did form a specialist group way back in 2016 on the conversion and redistribution of ATSC 3.0 services. So this group has been meeting for a number of years, coming up with standards and recommendations for how to convert that 3.0 signal and make use of that 3.0 signal for MVPDs. And this group also talks about reuse for low power translators and even apartments and other distribution systems that may have distributed those ATSC 1.0 signals. We're mainly focused in this webinar on the MVPDs reuse, so as of December 11, 2019, the recommended practice ATSC A370 was released by this group, and it is titled Conversion of ATSC 3.0 Services for Redistribution. And I've read through it a number of times. I think it does a really good job of explaining how to get an exact ATSC 1.0 signal from the 3.0 signal. And that's really good. My question, kind of posing out there is, do MVPDs really want an exact ATSC 1.0 replica? I would dare say they don't really care about the majority of that. So I think a lot of this A370 recommendation is a little overkill for most MVPDs and their needs. And we'll talk about that in the coming slides. What might an MVPD really need in that conversion, and what don't they really care about? So yeah, let's jump into some of the recommendations. I did kind of get a kick out of this block diagram that was in the A370 standard. This is kind of the all-in-one, any input, any output ATSC 3-to-1 converter box that the A370 recommendation proposes. I'm not sure anybody's going to quite come out with a single box that does all this in one for a reasonable cost or in a reasonable time frame, but it's certainly a goal that you being able to take in ATSC 3.0 as RF or IP, and being able to output that as IP, ASI, RF, SDI, and Ethernet with all the proper conversions in the middle. So I thought it's a good try. I'm not sure how practical it is in the real world. We can talk about that more as we go here. So the next few slides, I'm just laying out some scenarios on what MVPDs can really do in terms of being able to capture and stay on keep these local broadcast channels on their system through this transition to ATSC 3 and beyond. So obviously with some of the MVPDs already having microwave or fiber links to the broadcasters in their area, it's certainly feasible and probably preferable that those continue. And I think many of them will. So that's likely to be the primary way that many of these MVPDs get the signals. Broadcasters still likely have their ATSC 1.0 encoders, or their 3.0 encoders are capable of making a transport stream yet and sending that over, fiber to the MVPD. Like I said earlier, a lot of the MVPDs that I'm aware of are, using a fiber like this as a as a primary path, and then at the same time using the over-the-air RF signal as a backup. You know, as that RF signal changes, the backup solution is not possible. And certainly many rural and remote MVPDs would have trouble with obtaining a fiber to every local TV station, so many of them are going to need an over-the-air solution as well. So this is likely the primary way that most MVPDs continue getting these local network signals. You know, the other option right now is to use and receive the ATSC 1.0 simulcast. Like we mentioned earlier, those simulcasts are on the air until at least July 2023. They've got to be substantially similar to the ATSC 3.0 signal, but they are not mandated to stay HD if they were HD before. So it is possible that, you know, the MVPD, if they were relying on the simulcast, would have a signal that's not nearly the same quality as the ATSC 3.0 or even as the ATSC 1.0 was before. So, and you know, the biggest downside of this is you know, that cutoff of that ATSC 1.0 signal is potentially only 3 years away. So so this is really the you know, continue as is for now, and receive that simulcast, demodulate it, and continue to import that transport stream with the MPEG-2 video. Whether or not that's transcoded depends on the system, but this is at least a temporary solution to the reuse problem. So the third scenario I lay out here is really transcode of the ATSC 3.0 RF signal, and I think this is really what the, you know, that ATSC recommended practice A370 talks about, is how do we take the ATSC 3.0 signal in all its you know, glory, but all of its new technologies and codecs and things like that, and convert it into a signal that's reusable for most MVPDs. So, you know, that's you know, receiving the RF of the 3.0 and then running that through some kind of transcoder to convert the, you know, the HEVC and AC4 to codecs that are more suitable for the MVPD system. So, you know, either MPEG-2 or H.264 video, likely AC3 audio, maybe AAC. I'm not sure there, depends on the system, of course, but some kind of transcoder needs to be involved in this kind of process, because you know, most, if not all, of the MVPD current, you know, systems are not compatible with HEVC or AC4, and we'll talk about, you know, some of these transcode considerations in the next slides here. So obviously, if an MVPD is already transcoding, that would be less of a problem than it was if they're not transcoding. But certainly density is a big consideration here, right? Every single service would need a transcoder dedicated to it to be able to do this kind of processing. Transcoders are not inexpensive, certainly, and take a lot of horsepower and processing to do their work. So this is the third scenario we talk about. As we talk about needing to transcode, there's certainly a lot of considerations that need to be talked about when it comes to converting that 3.0 video signal to a video signal that is compatible with MVPD systems. So, and like I said, the A370 recommended practice certainly goes in depth into a lot of these considerations, and I'll just highlight a few of them. Obviously the ATSC 3.0 specifies HEVC video codec. I'd say, HEVC is very rare in most systems right now, and set-top box support is going to be lacking in a lot of ways. So most likely you're going to have to transcode that video to MPEG-2 or H.264. If, in the next few years, HEVC support becomes much more common, it certainly could be possible to, take the HEVC essence, without transcoding it out of the ATSC 3.0 signal and simply repackage it into a transport stream without doing the full decode, re-encode, transcode process in the middle, certainly saving some processing power there. But again, at this point, I think HEVC support in those systems is pretty lacking, and would necessitate a transcode into a different codec altogether. Beyond the codec, you've got the resolution, frame rate discussion as well. Obviously, some MVPDs are offering some UHD 4K channels. Most, I would say, are not. So likely, any kind of high resolution ATSC 3.0 signal would need to be downscaled. What do you downscale it to? That's an open question, but any kind of transcode would need to deal with that. 3D is certainly possible in ATSC 3.0. How to deal with that in doing any kind of transcoding or down converting would need to be dealt with. There's certainly the possibility of encoding both the stereoscopic images into different video streams and putting those together somehow. I'm not sure 3D's really gonna be too much of a worry for anybody in quite a while here, so maybe that one's a back burner. High dynamic range is definitely a consideration. We're seeing a lot of effort to use this HDR in ATSC 3.0. Those, that HDR will need to be dealt with in terms of being able to reuse that in these systems. Whether or not these MVPD systems support HDR is dependent a lot system to system, but likely some kind of HDR to SDR conversion will need to take place inside the transcoder to deal with that and make a compatible signal. Interlacing is another question. Interlacing was a question early on in HEVC. Some of the early standards versions of that didn't even support it. Seems like it's kind of worked its way in again. But many MVPD systems rely on 1080i signals. So a transcoder may have to de-interlace or add interlacing depending on the support needed. AFD is another one. The ATSC 3.0 signal does include an AFD mechanism in it. So the format, auto format descriptor, how to change from widescreen to 4:3. Certainly a transcoder would be able to follow any AFD that's in the 3.0 if it's doing a widescreen to 4:3 conversion, or maybe even preserving that AFD into the signal afterwards. So certainly some consideration has to be given there as well. As it relates to audio, ATSC 3.0 is making use of AC4 audio and all its complexities, but all its benefits as well. You know, I dare say AC4 support is very rare in MVPD systems and, you know, in set-top boxes. So most likely some kind of transcode will need to happen into AC3 or AAC. And as those transcodes happen, the transcoder and you know, the parties here will have to pay attention to channel mode. Like I said, you know, AC4 supports up to 12 channels of audio. How do those get mapped into, you know, AC3, 5-channel or 2-channel? You know, that's certainly going to have to be, any kind of transcoder is going to have to pay attention to that. Loudness is another big topic there. You know, the COM Act, you know, applies to ATSC 1.0 and will continue to apply to 3.0 and will obviously need to be preserved and converted through any kind of transcoding. So this A370 recommendation does have a number of recommendations on how to utilize the dial norm value and do that kind of converting without losing, you know, your loudness capabilities there, and dynamic range control goes along with it. So not only do we need to transcode the video, but we also need to transcode, you know, every single one of the audio services to make it compatible with an MVPD system. So if you know, if a MVPD is currently transcoding everything, they're just going to have to make sure their transcoder support these ATSC3 formats as an input. If an MVPD is not transcoding ATSC 1.0 right now, they may have to introduce that kind of transcoding into their system, which certainly adds quite a bit of cost and complexity here. The final thing to talk about in this section here is kind of the catch-all, right? It's all the other things that go along with the ATSC 3.0 and 1.0 signals. Closed captions is a big topic. You know, mandatory, FCC required. There's certainly penalties associated with not properly passing or maintaining these captions. So something definitely has to happen there. Like I said earlier, the you know, the SMPTE time text includes the ability to put the actual raw 608, 708 coding inside the SMPTE times text. I haven't seen that been happening. So likely the you know, the transcoder will need to take the lines of text out of the SMPTE times text file and actually, you know, encode them as 608 and 708 to be able to put those into the signal for the MVPD. Definitely not the hardest thing in the world. There's plenty of tools out there to do that kind of, you know, on-the-fly text encoding into 608, 708, but definitely something that has to be paid attention to. Emergency alerting, you know, I think most MVPDs have their own kind of emergency alert system that's separate and not necessarily relying on these local broadcast stations to trigger. I think this emergency alerting probably applies more to the, you know, the low power translator type situations. But again, most MVPDs have an out-of-band system for doing emergency alerting, so I don't think it's too much of a consideration. The other thing, you've got the video and audio watermarks. This really shouldn't be a problem, and the A370 standard calls this out as well. These watermarks, you know, both in the video and audio are intended to be, you know, they were designed to be preserved through any kind of format changes, transcodes, those kind of things. So transcoding from 3.0 to 1.0 should definitely preserve those. So I don't really see this being a problem at all in the watermarking scenario. Service names, it's pretty straightforward to grab service names from the ATSC 3.0 signal and put those into the 1.0, the PSIP, things like that. So I don't think service names will be a problem. There's definitely action that has to be taken, but it's fairly straightforward. The other thing, you've got the ratings and the guide data. Again, probably not too hard to get the ratings pulled across as needed, but my guess is, and my understanding is, most MVPDs, have separate out-of-band systems for dealing with the guide data, and don't really rely on the guide data that's inside the the ATSC 1.0 signal. So most of that for MVPDs can probably be ignored and left be. So anyway, that's a lot of data there, going through different scenarios on how we're going to reuse ATSC 3.0 signals and still be able to pull those into MVPD systems. So I think we got a couple questions that we'll go over at this point. So.
Yeah, we did have one here, Seth. The question is, what's the expected worldwide acceptance of ATSC 3.0? And is SMPTE time text accepted worldwide as well, like for example in Latin America?
Sure. ATSC 3.0 worldwide, really we're on the air in the US here and in South Korea. How much it spreads beyond the US and South Korea is certainly debatable. I would expect Mexico and Canada to pick it up eventually here. Whether that filters down into Latin America, it's hard to say. A lot of the other countries have jumped on the DVB or ISDB standards and broadcasts over the last few years. So ATSC 3.0 certainly may be limited to North America and Korea at this point. So as far as SMPTE time text, that's a very widely accepted format. It's MPEG- makes use of it, right? So a lot of the OTT formats already use SMPTE times text. So I'm not, I don't think it'll be a big deal. It supports both ASCII and bitmap and non-ASCII characters. So I don't think there's any problem in supporting other languages and you name it. So yeah, SMPTE times text is very straightforward and usable and widely accepted is my take on it. So.
Yeah, so the next one I think is a little bit a question around how will ATSC 3.0 kind of interact with the uncompressed side, so doing a decode and also into the transcode. But the question is the ANC data applied as the SMPTE did SDID type format or encoded, the encoded version to pass in a different way? So does it change any of the DIDs and SDIDs and how that's being laid out?
Really, I think, it's going to be up to the decoder on how to map anything from 3.0 to 1.0, and I don't think there's really any kind of standard document or format for how to do that. I think certainly with captions that could come into play a little bit on how to map those into SDIDs and things like that, but I think it's going to really be somewhat proprietary as to how those get mapped from a decoding standpoint. Obviously, from a transcoding standpoint, it would hop right over that, and what the transcoder does in the middle is up to each vendor. But yeah, from a decoding standpoint, we'll have to deal with some of those ancillary data types. I don't have a clear answer on any of those at this point. So.
Okay. Do you feel that MVPDs won't want to give up bandwidth that ATSC 3.0 channels can take up? Many of the features like localized ad insertion, multi-channel capabilities, and internet additional components won't be ported over to the MVPDs.
Yeah, I really do see the MVPDs mainly just wanting to preserve the video and audio and not really caring so much about, the other aspects, benefits of ATSC 3.0. Obviously, like you said, most MVPDs have their own ad insertion capabilities already, so that will play into their decisions. The impression I get is most of the MVPDs want to maintain their requirements for retransmission, keep their customers happy, but don't have any intention of going above and beyond to make use of any of the ATSC 3.0 advanced features. So pretty much want to replicate what they have with 1.0 at this point. That may change in the future. So, in the last few minutes, I just want to touch on a few Sencore ATSC 3.0 product updates that relate to the topic at hand here and ATSC 3.0 reuse. So Sencore has been participating in and planning our ATSC 3.0 product rollout for many years now, keeping an eye on the market, the customer needs. And this year we've really definitely hit the gas on that in terms of a number of products and a number of product releases. So just trying to figure out where the market needs us, what products make sense, and how we can best help our customers there. So the product that relates most closely to what we talked about today is Sencore's TXS 3800. This product isn't quite released yet. We're kind of coming down the home stretch in terms of releasing it, but really this is a appliance-based product for doing 3.0 to 1.0 transcoding that Sencore plans to release very early in 2021. So this will have the ability to receive ATSC 3.0 RF channels, transcode multiple services from within those channels, two transport streams with MPEG-2 or H.264 video and AC3 or AAC audio. It will have the ability to transcode the captions into an appropriate format, and will have outputs for that transport stream as ASI or IP. So definitely, like I said, targeted exactly at the topic of this presentation and making a solution for MVPDs that need to early on do some of this transcoding. So definitely, if you have need for this kind of product, don't hesitate to reach out to Sencore, and we'll give you information and details about this product and its upcoming release. So, couple other products that we have for ATSC 3.0 that are available right now. So we've got our SLM 1530 handheld signal level meter. This was released back in June. Had a lot of great feedback and uptake on this. A lot of customers using it as they roll out RF signals of ATSC 3.0. So we're excited to have this out here. It does decode full motion video and audio right on the screen. So definitely a handy tool to have with as these rollouts are happening. The other product that we've released already related to ATSC 3.0 is our terrestrial receiver decoder, so our ARD 3100 and 3400. So this is appliance-based decoder, receives the ATSC 3.0 RF and can decode from 1 to 4 services simultaneously from those signals to baseband video, SDI or HDMI at that point. So just a very stable tool for for customers to use in labs, you know, decode for re-encode, and certainly feeding video walls and other things where ATSC 3.0 signals are available. Sencore is also the preferred distributor for DekTec in North America, and we've got a number of great little DekTec tools for labs and for ATSC 3. So test modulators allow us to you know, reproduce ATSC 3.0 signals in a lab or test lab environment. So we utilize these heavily here at Sencore and have helped many other customers get them set up for their own labs and reuse. And then you know, on the receiving side, the DekTec has a number of receiver cards for ATSC 3.0 and 2 pieces of software that go along with that, ATSC 3.0, ATSC 3 Expert for analyzing the RF side of it, and Stream Expert for analyzing the ATSC 3.0 content. That Stream Expert version that supports ATSC 3.0 is pretty new. That came out in July timeframe, and so definitely let us know if, contact us if you're interested in upgrading to that. Just some great tools for being able to dig in and look at your ATSC 3.0 signals and understand what's going on. So. And that's the end of the presentation and the webinar today. So we definitely thank you all for joining us. Any final questions as we go? So there is a vote on the screen that you guys should receive. So just let us know how you'd like us to follow up on this presentation, and we'll go from there. Otherwise, like I said earlier, the recordings for this will be on our website, and definitely look forward to you know, hearing from some of you if you've got interest or needs or opinions on this topic. So thank you all very much.